welcome to Soumya's Tech Talks. Today in this lecture we will discuss about functions in the C programming language. So here we will discuss following topics. So we will discuss about introduction to functions in C programming language and how does the function works. We will see what happens behind. So how the programming language or compiler do that function calls in the background. So we will discuss about stack memory, how it is used during function calls, and prologue, epilogue, and we will discuss about advantage, disadvantage, and we also discuss every concept with some sample programs. Let's start. So what is a function? So C programming language or any programming language, the function is a block of code, means group of instruction clubbed together, and you create a label for that, like you give a name, so that whenever you want similar functionality you can call that multiple times, which reduce the code redundancy. Like for example, you can have a function for sum, so whenever you need to add some variables you can directly call that function instead of writing the sum or addition code for multiple times. You can reuse the code. So we will see how it works. So to write a function, first we need to know the prototype of the function, means what is the syntax to write the function. So any function will have a return type and a function name, and you will pass a parameters, and so you will this starting brace, this curly brace start and end. In between you will write some instruction that will tell what this function will be doing. So first let's see return type. Return type is the result which you will return. Okay, you can in C or any programming language you can return only one result object. You cannot return multiple objects, only one. But parameters you can pass any parameter, number of parameters, but return type is only one. So if you don't want to return anything, you just keep it as a void. The keyword void you can place, so that you tell the compiler that you don't want to return anything. Return type, you can return a integer, character, sort, like primitive types, and you can also return structures, pointers, reference. We will discuss what is structure, object, pointers in the later lectures, but you can also return this kind of complex object. So function name, you can give any meaningful name, and you should follow some coding guidelines so that the name reflect the, like you can have, if you are doing sum addition, you can give the name as sum or addition, so that it is understandable by any other programmers what this function is going to do. Okay. So parameters, you can pass multiple parameters separated by comma, and each one have a name. You can give any name and a type. Okay. So we can use these parameters inside the function code instructions. Okay, like return type, you can pass any parameters, primitive types or complex objects like structure, object, pointers, everything you can pass. This is the prototype of the function. So we will see how we can use this prototype to create some functions and see how it works. So function have two things. One is declaration and definition. So declaration means you just define it. You don't write the code logic. You just define like this: int sum ab and semicolon. It tells that you are having a function called sum, which returns a integer, and it takes two arguments. So you are telling that this I will be having this kind of function, and I will give the definition later point. So this is the definition. Okay, and this is the declaration. So definition is you have to write the actual logic for the function. So you will write like this. So you will return a plus b. So you will sum and return the result. So either you can have both together, means you can have definition and declaration together, or you can have declaration at multiple places. Wherever you want to call this function, you can have that declaration, and you can have definition at one place. Okay. So you cannot have definition of a function multiple times, which gives you compile error. And also you declared it but not defined anywhere, it will give you link error. Linker will tell that some function it could not find some function. Okay. Yeah. Okay. Now we see how to declare a function, how to define a function. Now let's see how we will call. Okay. So to call the function, you just, like you can see here example, there is two functions, one is average, one is sum. So in main function I call this average, the name of the function, and I can pass the parameters, arguments I can pass. Okay. Once defined, you can call that function from any place. Like if your project is having multiple files, then there is some rules with that we will discuss in later lectures. For now you can note that once a function is declared and defined, you can use it from your code from any place. So a function can call another function also. Let's say average function call some function. This is called nested functions. So one function is calling another function, and also same function can be called itself. This is called recursion, means you can call a function and inside that you can call same function with different parameters or same parameters. So this is called recursion. Okay. So now we will discuss the return statement. Means every function should return some result. If you don't want to give any result, you can keep it as void. So the return statement is return keyword plus optional value. Means value means you can return a value, hard coded value like a digit or anything, or you can return a variable, you can return a pointer, structure, anything you can return. Okay. If a function is non-void return type, then it must return a value, otherwise you will get the compile error. Okay. And also you can if you are void function, like you have a return type void, you no need to have return statement. By default it will return at the end of the last instruction. So also you can return conditionally, like you don't want to, upon some condition you don't want to execute the instructions and return from the function. So you can do that. Like here if you see average function, if x and y both are 0, I don't want to do any average, so I can check and return from here, so that the after return statement no instructions will be executed. So like this you can return from here on a condition. Okay. So let's see the main function. So every C program have the main function. So it is the entry point of your application program. So if you don't have main, your program never runs. Okay. So it will have a int return type which gives 0. If it is always by default it will give 0, or you can give any error type 1 or something, some error, but by default it is always written 0. So you can have a int main with no arguments. You can pass arguments like argc, int argc. Like here you can tell how many arguments you are passing and array of the arguments. Okay. We will discuss this later lectures, how to do this. And so if you have arguments in main, while launching the application from command line or somewhere, you can pass those arguments. So here you can see the example, like I have a main function with no arguments and print and return 0, and I have some arguments. So here I having loop and print all the arguments. Okay. You can refer this example and try it yourself. So this is the main function. Now let's see, actually when you write code, your C program with functions, so it will be handled by the compiler by default. So you no need to worry how it works, what happens in the background when you call a function. Everything will be handled by your compiler and runtime environment. But as a programmer, to fix the bugs or to know more about this, to write the efficient programming, you need to know how the function call happens in the background. So in the function call, let's say in any embedded system or operating system, Windows application, or you can have Android or Linux application, or as a embedded system which have only one application for the entire system. So in any case, your RAM is divided into multiple sections. Okay, we will discuss this later. Like text means your instructions will be stored, data means global variables, we will discuss it later. But here in case of function execution, the main memory segment is stack. So today we will discuss more on the stack. Okay, so here you have a rectangular box, so which is one block of memory. So your operating system will support either you can one block is 32 bit or 16 bit or 64 bit. It depends on what kind of CPU or processor architecture, like Intel, ARM, like that. So here we will focus more on the stack memory, how it is used during the function call, and we will learn how the function call happens. So like if you see the stack memory, it is like the memory normally grows from the incremental order, ascending order. Like the memory start from 000 and it will see what, let's say you have a RAM of 1 GB and it will start from the address 0000 and till some higher address like XFFF something based on your RAM size. So the memory generally start from 0 and grows like this, but stack normally start from the it grows in reverse order, like it start from bottom and grows. So it is stack is always behind the next to the heap. There is a heap which you have a memory for dynamic memory. We will discuss later, but right now you remember that the stack, we are interested in stack memory. So stack is below the heap and stack start from higher address and it grows whenever it will be at some higher address. When you insert a object into this memory location, it will jump to next one, like this it will grow in reverse direction till the heap. If once you reach this heap, end of heap, then you means your stack is full, you cannot insert more items. Okay, and there is a stack pointer register which keeps track of right now where your stack is, like how much you have filled. So it always, the stack pointer register points to current empty slot in the stack. Okay, so this is the stack pointer. Remember what is stack pointer, because we will use this in later discussion. So this is how the stack is looks. So stack, normally any operating system, stack will do two operations. One is push and pop. Push means you copy some data into that, where from where you copy, either from another memory address or from a system register. So you will give instruction like push space some register name or address, memory address you give. So from the data it will be pushed to the stack, and once you push, the stack pointer will be incremented, means the stack will jump to next location which is lower to this, means next to this, in reverse order. Similarly pop means you are removing some data from the stack. So what happens, one word will be removed, and let's say you are here, then one word will removed and stack will will come down. Okay, stack will be incremented means stack one empty slot will be created. So this is push and pop operations. We will see how these operations will be done during the stack. So whenever a function, okay, a call, right, it whenever you call a function, the previous function means the function which called it, let's say it can be a main or another function. So for that function a stack frame will be created. Okay, so the function which is called, another function is called caller, and let's say you call something from main is the caller, and the function which is being called means which will be executed is calling. You remember these terms. So whenever if function is called, a stack frame for the caller is created and it will jump to callee function, and once callee function is over, using the stack frame it will restore. Let's say you have a multiple instructions in the caller function, and at one instruction it call another function. So how it will resume from the next instruction using this stack frame. So what is the stack frame? The stack frame is a copy data that will be pushed to the stack. So what it contains? The arguments which is passed by the function. Like earlier the function is called with some argument that will be stored, and return address. Return address means after the execution of new function where to return, and some register also backup, like you will take backup of some registers, so that in new function if these are overwritten, so to avoid overwritten means you store temporarily in stack. Once the new function returns, you will copy it back to the registers again from the stack. So this is the stack frame created whenever a function is called and ready to execute before execution. Okay. So now let's see, in CPU you like stack pointer, you have one more base pointer, stack base pointer, which is a reference. Like in your stack frame, like it will tell where is your it always points to a pointer where you have started your local variables of the new called function. Okay. So why we need a stack base pointer? Because your stack pointer will be incremented and decremented when you push and pop. So but you need to know where your local variables of the function started. So to remember that address, there is a base pointer. We will see in later lectures how it happens, but remember that this base pointer always when you have arguments, return address, and some registers are stored, everything, and after that the function has some local variables, it will be stored. So your base pointer always points to the place where the stack address where you start the local variables. So that is the base pointer. Okay. So now let's see more detail. Whenever a function is called, so what happens? So let's say you call a function from another function, from main for example. So first before execution what will be done? So the arguments you have passed will be stored into the stack. So let's say you have passed 3 arguments. The 3 arguments will be pushed to the next 3 contiguous stack. Sometimes in some architectures the arguments will be stored in the registers, and some architectures it will be stored in the stack. If it is stack, the arguments will be pushed to stack. Okay. Then what it will do? Next step, return address of the caller, means once the current function executes, so where the return address, from where the execution will resume again. Okay. Let's say you have a function and you have 4 or 10 instruction, and 5th instruction is your function call. So this return address is 6th instruction, like your instruction address of the instruction which will be executed once this function is returned. So that will be stored, and any registers, like if you want to back up any register, that will be backed up. So after that there is a prologue happens. Prologue means the base pointer of the caller stack, like the caller's local variables where it is stored, that address will be pushed to the stack. So it will remember the previous caller's base pointer, and it will create a new base pointer for the current call function. So what is the new base pointer? So once you push everything into the stack, so the stack will grow and it will have the current stack pointer, means current stack address is treated as the base pointer. And what you will do? You will create a space for the local variables of the new called function. Means you have called a function, let's say you have 4 variables declared. So that space will be reserved here. So this base pointer always points to the starting of the local variables. Okay, and if you don't have local variables also, this will be created. Okay, so this base pointer is very easy to using this you can easily access your local variables and function arguments, everything. Okay, then function will be executed and it will be written. So once written, epilogue will happen. So what happens, first it will remove all local variables created, because the function execution is completed, there is no need of local variables, they will be deleted. And whatever backed up register values, let's say you have some system registers, so for the caller they have stored backed up, so that data will be removed from stack and stored back, restored to the registers. Okay, and all register, everything will be restored and stack will be pointed back to the caller's base pointer and it will be restored. Okay, now let's see one example step by step. Let's say you have a main function and sum function. So in main function I am calling sum. So here what happens, initially step 1, main is the first function, right? So the stack is empty, so there is nothing in the stack, it is pointed, let's say it is pointed to some 0xFFF some location. Okay, so now what happens, sum will be called, then what happens, your first arguments will be pushed to the stack and stack will be decremented and it goes to FFF, FED, FD, you can see, and A and B is copied to the stack. So next what happens, so once you did this, prologue happens. What prologue happens, it will take previous callers, means you have called from main function, so main function have a base pointer address, so that will be stored here, and then local variables, like you have a 2 local variables in sum x, y, so memory will be allocated on the stack for that, and the sum functions base pointer will be this one. So where the starting address of local variables, like here where the x is stored, that will be treated as base pointer. Okay, so now stack is everything is stored. Now stack pointer see here, but your base pointer is here. So you can easily access these local variables arguments using this base pointer. Like if you base pointer +1 or +2 you do, you will get all the arguments passed. Like that, using the base pointer, the execution, the function instructions can easily access the variables. That's why this base pointer is happen, and then once prologue is completed, the function will be executed. Let's say function is executed, then it will return. We'll see what happens when return happens. So first it is executed and it will remove, make the stack pointer as your base pointer, means all your local variables, everything will be deleted and it will come here, and it will restore the previous caller's base pointer will be restored. Okay, so the RPB register will be copied back with the caller's base pointer and everything will be deleted, all arguments, everything pop, and your stack will be at the position where it was earlier before executing of the sum. So this is how the stack happens. So you no need to worry, because everything is taken care by your hello all, thanks for watching. This is the end of current lecture and we will continue with more lectures. Please share these videos and tutorials with your friends who are interested to learn. Bye for now.